Now that we've all downloaded the dataset from UNICEF, let's jump right into an introduction to Dplyr. Dplyr is a helpful data manipulation package with 5 main functions, including filter, select, arrange, mutate, and summarize. In this introduction, we'll be focused on the first 3 verbs, filter, select, and arrange. So first for filter, filter is used to view a particular subset of the data. For instance, if we wish to view the percentage of women between the ages of 18 to 19 years old in Albania who received antenatal care, originally in R, we would first start by specifying the health data set and then say where the age is equal to 18 to 19 years old, location is equal to Albania, and then our 4 antenatal health indicators, which correspond to the percentage of women who received care during her first trimester, the percentage of women who had more than 1 doctor's visit during the course of her pregnancy, the women who received more than 4 doctor's visits during her pregnancy, and the women who had more than 8 doctor's visits during her pregnancy. Now let's run this line of code, and we can see that the result is a table with rows 6 and then 10 columns. We see that the location is Albania, our age is 18 to 19 years old, our indicators all are 4 antenatal health indicators, and our value corresponds to the percentage of women who responded positively to each indicator. So for instance, the first row would correspond to 83% of women in this survey from Albania saying that they had 1 visit to their doctor during the first trimester of their pregnancy. Now, to achieve the same result in Dplyr, we would run this line of code. Now, before I run it, let me just talk a little about the formatting of this code. It might be new to some of you. So, for instance, this percent greater than percent simple means then. So the way that we would read this code is the health data set, then we filter. The way of writing this is called pipelining or chaining, and it's really just for if you're using multiple functions at once, especially if you're using Dplyr or tidyr. This is very useful so that you don't get confused. So we'll run this line of code, and we can see that the resulting tibble is the same as before. And now you may be thinking, what's the advantage of using Dplyr if you can achieve the same result in R? Well, by looking at these separate lines of code, we can see that Dplyr allows you to achieve the same result with fewer lines of code. For instance, when we created the tibble with default R, we needed to continually specify the dataset we are working with and rewrite each variable several times. Thus, Dplyr allows for cleaner and simpler code. Note this will be a common theme throughout this tutorial. Now let's move on to the function select. Now select allows you to view only columns of interest in a data set. So for instance, if you want to view only the location, indicator, and year columns of the health data set, originally in R you would write the health data set including all of the rows, but where the columns are labeled location, year, and indicator. Now let's run this line of code, and we see that the resulting tibble is 31,821 rows by 3 columns. Thankfully, the tibble only printed 10 of those rows. This is why we print in a tibble. Now, the tibble has location, year, and indicator. And now to run the same line of code or achieve the same result in Dplyr, we can specify the health data set, then using the select function, we can say select the columns named location, year, and indicator. The result is the same. And now you may be wondering what the advantage of using Dplyr is in this scenario. Well, the advantage is that the select function does not require the use of quotations, and we also don't need to worry about stating that we want all of the rows. Now, the select function in Dplyr is also great to use because it allows for more functionality. So for instance, select allows you to view columns in a sequence. So for instance, if you wanted to view all of the columns between the columns named location and value in the health data set, except for the one named source, using the select function from Dplyr allows you to do this. So first we're going to say the health data set, then select the columns labeled location through value, and then deselect the source column. Now when we run this line of code, we see that the resulting tibble is exactly what we wanted to produce. It has location through value, but subtracting the source column. And now select also allows you to view columns with a specific word in its name or title. So for instance, if you want the health data set, then selecting only the columns that contain the word indicator in it, we can create this tibble. And now we can see that the resulting tibble is only a column with the word indicator in it. Now let's move on to an example of combining filter and select. So if we want to view only locations where the percentage of females who use contraceptives is greater than 20, we can use filter and select in Dplyr to achieve this result in a cleaner and simpler way than we would need to write it out in R. So originally in R, we would say the health data set where the health indicator is CPMODHS, and this is just a label that corresponds to contraceptive use. And the percentage or value is greater than 20. We also want to select columns, location, year, indicator, and value. So when we run this, we have a tibble with 632 rows and 4 columns. And now we can also see that all of the percentages are greater than 20%. We can achieve the same result in Dplyr by writing the health data set, then selecting for the location, year, indicator, and value. And then filtering the indicator column by contraceptive use and where the percentage is greater than 20. Again, the resulting tibble is the same, but Dplyr allows you to write it in a cleaner, simpler way that's more understandable than default R, where you would need to include brackets and also specify columns in this string. Finally, we can move on to the arrange function. So arrange allows you to sort one column by another. For example, if you wish to sort location by the percentage of women who gave birth in an institution, and sort this from lowest to highest percentage of women, originally in R, we would first have to create a new subset of the data, and I named my new subset health_deliv. So this is the health data where the indicator is I_deliv, and this just stands for all of the columns that contain the indicator I_deliv or institutional delivery, and then all of the columns. Now that we have that subset, we can say the subset and order that subset based on the value or the percentage of women, and include columns, location, year, indicator, and value. So now we have a tibble of size 1,246 rows by 4 columns, and you can see that it includes location, year, indicator, and value. And at the top, we see that a small percentage of women responded yes to having an institutional delivery in 1993 in Bangladesh. To achieve the same result in Dplyr, we first specify the health data set, then select the location, year, indicator, value, and value columns. Then we can filter these columns by the indicator I_deliv, so whenever a woman had an institutional delivery, and then arrange these columns by the value or the percentage of women. So when we run this line of code, we see that the resulting tibble is the same as before, but again, Dplyr allows you to write it in a more concise and easily understandable way, and you don't need to create a separate subset of the data beforehand. Instead, you just need to use the functions select, filter, and arrange. Note that the default in Dplyr is to sort by ascending order. If you would like to sort by descending order, add the argument DESC to the arrange command. So for example, if you want to sort by the percentage of women who had a skilled attendant for her institutional delivery and sort this from highest to lowest percentage of women, we would say the health data set, then select the location, year, indicator, and value columns, then filter by the indicator SBA, which just corresponds to whether or not a woman had a skilled attendant for her institutional delivery, and then arrange these columns in descending order by the percentage of women. So when we run this, we can see the resulting table with dimensions 2,347 rows by 4 columns shows that in Albania, 100% of women involved in this survey responded to having a skilled attendant for her institutional delivery. Great, now we can move on to an introduction to TidyR.